Okay, so this is where it really starts to get fun. We're going to talk about linear and quadratic functions. So we've done linear functions. They're just lines, equation of a line. We know that they're a function because for each x coordinate, there's only one y coordinate that matches with it. Okay, but we're also going to talk about quadratic functions. So we did quadratic equations when we did all that factoring back in chapter 5. So now we're going to look at how we would graph those. So a function f defined by f of x equals mx plus b is a linear function. Okay, so we're very familiar with these now. If the domain of f is a set of real numbers, then its graph is a straight line with slope m and y-intercept b. Okay, so here's an example of a line. If I look at this, here's my y-intercept. So my y-intercept is at 0, 4. And here is my x-intercept, which is -2, 0. Um, from that, I can find my slope. So we'll have the slope is 4 minus 0 over 0 minus -2, which is 4 over +2, which is 2. So there's my slope. We already know the y-intercept is 4. So I can write this as f of x equals 2x plus 4. Okay, so basically all I've done is write the equation of a line. The only difference is it's a function. So I'm just using function notation. That's the only difference with this is function notation. Okay. So a function f defined by f of x equals ax squared plus bx plus c, where a is not equal to 0. If a was 0, then this would just be bx plus c. So this is standard form of a quadratic function. Okay, so we've factored these. We would solve this for 0, and then we would factor. Okay, so this is a quadratic function. So if the domain of f is the set of real numbers, then the graph of f is a parabola. So this shape here is called a parabola, not a parabola, a parabola. Okay, if a is positive, the parabola opens upward. So here it is. It's positive, so it's opening upward. If a is negative, the parabola opens downward. So this is a positive a, and this is a negative a. Okay. So the coefficient of your quadratic term, your a, its sign determines whether it opens up or down. Okay. The x coordinate of the vertex of the parabola, y equals ax squared plus bx plus c equals 0, is negative b over 2a. So this is the vertex. So the highest point or the lowest point is called the vertex. And we can find the coordinates of the vertex. The x value is going to be negative b over 2a. So if we have our equation, this is our equation standard form. Whatever b is, I take the opposite of that. Whatever a is, I multiply it by 2, and I write this fraction, and a lot of times it simplifies to a whole number. That is the x value of my vertex. So my vertex is going to be xy. So that's the x value of my vertex, okay, because it's going to match up with this. And we have what's called an axis of symmetry, okay, which goes through the vertex. And you'll notice that the parabola is symmetric about that. It's a vertical line, and the parabola is symmetric about that. So the equation for this line, for the axis of symmetry, is x equals negative b over 2a, okay, which makes sense because it's a vertical line, and vertical lines are usually x equals a number, okay. Told you this was fun. All right, so here's my first example. I have g of x is equal to x squared minus 2x minus 3. And I'm going to graph this, okay? And I didn't give you a graph, and I apologize for that. So let's start with finding what first of all, let's determine, does it open up or down? A is just 1, which is positive, so it's going to open up. Okay, that's the first thing. If we know whether it's opening up or down, that's a help right there. Because in this case, A is equal to 1, B is equal to -2, and C is equal to -3. Okay. I can find my x coordinate of the vertex. So let's find the vertex. We have the x coordinate is going to be equal to negative b over 2a. So the opposite of b, if b is -2, its opposite is +2. A is 1, so it's just 2 over 2, which is equal to 1. So there's the x coordinate for my vertex. So my vertex is at 1 something. Okay. The y coordinate what I do is I take my equation, okay, x squared minus 2x minus 3, and I plug in this value, okay? So whatever this x was, I plug it in because this is really equal to y. So what is y when x is equal to 1? Well, let's plug it in. So we have 1 squared minus 2 times 1 minus 3, okay, which is equal to, I don't know why I put that in parentheses. That's just weird. We have 1 minus 2, which is negative 1 minus 3 is negative 4. Okay, so there is the coordinates of my vertex. Okay, we know that the axis of symmetry is x is equal to 1. All right, so let's get graphing on this. So I'm going to draw my graph over here. Okay, and I'm going to start by graphing my axis of symmetry. So that's where x equals 1. I'm going to put it in as a dashed line so I don't get confused. So there's my axis of symmetry. My vertex is 1, negative 4. So here's 1, 1, 2, 3, 4. There's 1, there, negative 4. So there's my vertex. And I know it's going to open up. So it's going to be kind of like a U-shaped. So here's what I'm going to do. I'm going to pick points. I need at least 3 points, but I'm going to do 4. Because the parabola is symmetric about this axis, I'm going to pick points on either side of the axis. So if the axis is here, my dash line isn't very good. At 1, if I go 1 in this direction, my x is 0. And if I go 1 in this direction, my x is 2. And they should have the same y coordinate because it's symmetric. So if I plug those in, if I plug in 0 up here, I'll have 0 minus 0 minus 3. So this is just negative 3. If I plug in 2, I have 4 minus 4, which is 0, minus 3. So as you can see, these are symmetric points. So I'll have 0, negative 3, which is right here, and 2, negative 3, which is right there. So see how I'm starting to make this symmetric? And it would look even more symmetric if I used an actual coordinate plane rather than the scribble that I did. All right, so now let's pick 2 more points. So I'm here. Now I'm going to go 2 spaces in that direction, which is negative 1, and then 2 spaces in the opposite direction, which is positive 3. Okay, and these should both give me the same y value. So if I plug them in, this is going to be 1 plus 2 is 3, minus 3 is 0. And here I would have 3 squared is 9, minus 6 is 3, minus 3 is 0. Okay, so it makes sense. You always want to do these in pairs to make sure you're not making a mistake. So I have negative 1, 0, which is here, and 3, 0, 1, 2, 3, which is here. And again, it continues to be symmetric. And this is actually a curved line, so you kind of draw it with a curve. Mine's kind of sloppy, but that's basically what it looks like. Here's my vertex, 1, negative 4. That's my vertex. Here's my axis of symmetry, which is x is equal to 1. Okay, so your axis of symmetry is always x equals a number. All right, so let us look at the try this. Find the vertex of the graph a of x, where it's 3x squared minus 12x plus 1. So first of all they're asking for is the vertex. So I don't have to graph anything. Let's start by finding the x coordinate of the vertex, and that's going to be x is equal to negative b over 2a. So my a is 3, my b is negative 12, and my c is 1. We don't use 1, or we don't use c, but in other courses you will use c. It's a good idea to just identify what c is. So I have the opposite of b. So b is negative 12, so the opposite will be positive 12. A is 3, 2 times 3 is 6, so this is going to be 2. So there is my x coordinate. To find the y coordinate, I plug in 2 for x. So I have 3 times 2 squared, because it's what is the value of y when x is 2? That's the vertex. Minus 12 times 2 plus 1. So I have 3 times 4 is 12, minus 24 plus 1. That would be negative 12, so negative 11. Okay, so I should have a negative 11, which is a good thing we're not graphing it. So there is my vertex, 2, negative 11. Okay, and if we look at number 2, it says give the equation for the axis of symmetry. Well, with the axis of symmetry, we said was x is equal to 2. okay, because we already found what x was. And that is that.